Welcome to the DIY Honda Garage channel. The DTC P0722 indicates an issue with the output shaft or countershaft speed sensor that reports no signal input. This sensor plays a critical role in monitoring the speed of the output shaft, which is essential for the proper functioning of the automatic transmission. The sensor is located on the transmission housing, typically near the point where the output shaft emerges. It sends signals to the powertrain control module, PCM, to help determine the appropriate shift points of the transmission. When this code appears, it often points to an electrical issue in the circuit rather than a mechanical failure, as specified in the troubleshooting narrative. Therefore, addressing the electrical connections or the sensor itself is imperative to resolve this diagnostic trouble code. The DTC P0722 indicates a failure in the output shaft speed sensor, specifically no signal being sent to the powertrain control module, PCM. Located on the transmission assembly, this sensor is crucial as it transmits the rotational speed of the output shaft. It's responsible for providing data to the PCM, which in turn adjusts transmission fluid pressure and shift timing for optimal performance. A malfunction in this sensor leads to improper or erratic shifting, negatively affecting vehicle operation. The failure usually arises from electrical issues rather than mechanical failure within the transmission system, clarifying that a detailed electrical diagnosis is necessary. There are several potential causes for DTC P0722. One is an open circuit, which could disrupt the signal traveling from the output shaft speed sensor to the PCM. This often results from damaged wires or connectors. Another cause is a shorted wire, particularly in the NC, not connected line, which could cause the sensor to incorrectly report a zero speed signal back to the PCM. Lastly, the issue could arise from a faulty speed sensor itself, which may need replacement if the electrical tests confirm the circuit is functioning properly. It's crucial to check each possibility systematically to effectively narrow down the root cause of the issue. When DTC P0722 triggers, you might experience various symptoms. Erratic shifting is common, as the PCM relies on speed data to dictate shift points. Without accurate information, shifts can either be delayed or occur too early. You may also notice the check engine light illuminating on the dashboard, signaling an issue that needs addressing. Additionally, poor acceleration performance could occur, as the transmission may not engage correctly if the output shaft speed data is faulty. These combined symptoms significantly impact the driving experience and vehicle reliability, making timely diagnosis and repair essential. The first step in troubleshooting DTC P0722 is problem verification. Begin by turning the ignition switch to the on position, I. Next, clear the existing DTC using the Honda Diagnostics System, HDS, to eliminate any previous faults. After that, securely block the rear wheels and lift the front of the vehicle to allow the front wheels to rotate freely. With the engine running and the Vehicle Stability Assist, VSA, disabled, drive the vehicle at a speed exceeding 12 miles per hour, 20 kilometers per hour, while in drive. During this time, compare the input shaft, main shaft speed, and output shaft, countershaft speed as recorded by the HDS. If the speeds are similar, it indicates an intermittent failure, suggesting the system may temporarily be functioning correctly. Otherwise, proceed to the next troubleshooting step. In this second troubleshooting step, we will check the VCC1 line to verify the electrical connection to the output shaft speed sensor. Begin by turning the ignition switch to lock, 0, and then disconnect the speed sensor's 3P connector. Next, turn the ignition switch back to the on position, 2. Measure the voltage between the specified test points with the output shaft sensor connector still disconnected. The test points include the VCC1 wire at pin number 3, which is typically a yellow-red wire, and a body ground. You're looking for approximately 5 volts. If this voltage is present, it indicates the VCC1 wire is intact. If not, focus on repairing any breaks or damaged connections in this wire running from the speed sensor to the PCM before advancing to the next step. The third step involves determining the potential failure area by measuring the voltage in the NC line of the output shaft speed sensor circuit. Ensure that the ignition switch is in the on position, 2, and the sensor's 3P connector is still disconnected. Measure the voltage between the second test point, which corresponds to the NC wire at pin number 2, typically a black-white BLK-WHT wire, and a body ground. You should again see close to 5 volts. If this voltage is present, it suggests that the NC line is functioning correctly, allowing you to proceed to the next step. However, if the voltage is absent, you need to check for issues within the NC line circuit towards the PCM or require further inspection into what could be causing the interruption. The fourth troubleshooting step is to verify the continuity of the SG1 line, which is critical for communication between the output shaft speed sensor and the PCM. Start by ensuring the ignition switch is in the lock position, 0, and disconnect the sensor's 3P connector. Then, using a multimeter, check for continuity between the SG1 wire's test point at pin number 1, PCM, and a body ground. If continuity is confirmed, it indicates that the SG1 wiring is intact, permitting movement to the next diagnosis. On the contrary, if you find no continuity, it signifies an open circuit that needs repair between the output shaft speed sensor and the PCM before further steps are taken. In this fifth step, we focus on checking for a short condition in the NC line, which could prevent proper signal transmission. Make sure the ignition switch is in the lock position, 0, and jump the SCS, service check signal, line using the HDS. After this, disconnect the PCM connector B, 49P, to isolate the circuit. With the output shaft speed sensor connector still disconnected, measure the continuity between the NC test point at pin number 2, black, white, black, and body ground. If continuity is detected, it indicates a short to ground in the NC wire that needs repair before you proceed. Conversely, if there's no continuity, it suggests the NC wire itself is open and should be guided back toward the PCM for repairs. The final repair verification step is essential in ensuring that the DTC P0722 issue has been resolved effectively. Start by reconnecting all related connectors to ensure proper electrical connections are restored. Next, turn the ignition switch to the on position, 2, and clear the DTC with the Honda Diagnostic System, HDS, to reset the fault memory. After clearing, start the engine and disable the Vehicle Stability Assist, VSA, by pressing the VSA off button. Again, run the vehicle with the shift lever in drive at speeds over 12 miles per hour, 20 kilometers per hour, and recheck the input shaft speed and output shaft speed using the HDS. If the speeds are aligned as expected, it indicates that the issue has been fixed. Otherwise, further inspections may be needed. To prevent the recurrence of issues related to DTC P0722, a proactive maintenance approach is recommended. First and foremost, regularly inspect the wiring associated with the output shaft speed sensor for any signs of wear, fraying, or corrosion that might compromise functionality. Additionally, monitoring sensor performance through periodic diagnostic checks can help catch smaller faults before they escalate to serious issues. It's also a good practice to check for any available updates for the powertrain control module PCM. as software updates can enhance performance and potentially address unresolved bugs. Consistent cable management and protection can go a long way in ensuring sustained and reliable operation of the sensor system. In conclusion, DTC P0722 is associated with the output shaft speed sensor reporting no signal input and indicates a need for thorough electrical diagnostics. Following the outlined troubleshooting steps systematically ensures that the root cause is identified, whether it involves an open circuit, shorted wires, or a faulty sensor itself. Proper verification of voltage readings and continuity checks play a critical role in diagnosing the problem accurately. Once repairs have been executed, final verification ensures that the issue has been resolved, safeguarding the vehicle's reliability and performance. By implementing good preventive maintenance practices, such issues can be avoided in the future, ensuring the longevity of the vehicle's transmission system. Please like and subscribe to the channel. See you next time.